So we have a pottery wheel, and the first question is asking us what's the torque needed, what's the torque of the potter's hands on the pottery, and then given that we have that torque, how long will it take for the uh, the wheel to slow down essentially? So we have the angular velocity of 1.6 revs per second. And we can also say that we're going to convert and say this is 3.2 pi radians per second. And at this point, we can say, okay, the force of friction, we know this to be 1.5 newtons, and the diameter is 9 centimeters. And we can say the radius is going to be 0.045 meters immediately, convert to meters. And we know that the moment of inertia is going to be 0.11 kilograms per kilogram meter squared. So for part A, it's asking us for the torque. So this would be simply the force of friction times R, because this is constant. So if this is constant, that means that at least for the first part of the question, there isn't any angular acceleration, because the potter simply needs to counteract the torque done by friction in order for the wheel to have constant angular velocity. So this would equal T min. And we can simply solve, and this will be 1.5 times 0.045, and this will equal 0.0675 Newton meters. So this will be your answer for part A. And then part B, they're asking us, okay, how long will it take for it to stop given this torque? So torque is also equal to I alpha, which means that alpha is going to be equal to the torque divided by the moment of inertia, I. This is going to be 0.0675 divided by 0.11, and we find that this is going to be 0.6136 radians per second squared. Now again, this is going to be slowing down. So because this is slowing down, this is actually going to be negative. So we can say equals negative 0.6136 radians per second squared. And we can use the negative value in order to find the time. So we can say that our omega initial is going to be 3.2 pi radians per second. And then we have that omega final equals omega initial plus alpha t. We know that we want the wheel to stop. So the angular velocity is going to be 0. The final angular velocity is going to be 0. And then we have negative omega initial over alpha equals t. And this is going to be negative 3.2 pi all over negative 0.6136. And this is going to equal 16.384 seconds. So this would be your answer for part B. This is how long it takes for the pottering wheel to cease motion, given that we have a torque applied by the potter himself. And that's the end of the solution. Thank you for watching.